Hello everyone, my name is Russ Grease, and today I'm going to be continuing on my EPG, Stan Meyer's EPG system. This is going to be a more informational video, and it's going to be part 3 in the series. So today I'm going to talk about what kind of tubing. Again, I've got some new information on that. The particle generation, we got more information on that, and the core material for the primaries, and more information about that. But I'll get to that all in a minute. First I want to say thank you. Everybody's been very helpful. The best way to get a hold of me is probably my email. YouTube messages are great. Comments are awesome. That works fine. But if you send me a YouTube message, you'd be better off just sending me an email. It's rwg42985@aol.com. I'd also like to thank everybody who's contributed either their time, their resources, or all of the above. I am asking for any funding money. If you'd like to send it to me, you can email it to me via PayPal. Email address rwg42985@aol.com. If you can't contribute that way, I do have a parts list. If you can contribute any parts or pieces of anything you may have, or somebody you may know may have. If you can't do either of those, if you can volunteer your time, do your own research, look at this stuff, look at everything I'm giving you, and then give me feedback. That is a very, very good way to donate what you can if you don't have any of those other things. And if you don't, I understand what kind of boat you guys are in. I'm in the same boat as you are. Totally understandable, and let's just do something together. Let's build this together. There is a guy by the name of Matt, and he has donated his time and his resources, and he's actually building a website to help gather up more information and put it in one central location. So when that time comes, I'll give you that email address. Alright, so thank you everyone. First of all, I want to say thank you. Another thing I want to say is thank you to Alex Petty. Alex Petty's been doing a lot of research on this prior to me, and if it wasn't for him, probably never would have looked at this stuff. So thank you, Alex, and look up Alex Petty's website. I'll put it in the description, as well as everything else. I'll put it in the description as well. Alright, so let's get started. The first thing I'm going to talk about one patent today. I don't want to make this video too terribly long. It's the Canadian patent again, that very first patent, and the number is right there, 1213671. It's called Electrical Particle Generator. And what I want to talk about is the particle generation. That's one thing that a couple people who have been working on this, we've been discussing in the comments below the videos. What's going on, how do we make this, and then how do we test the gas. The best way to test the gas, in my opinion, would be build a particle accelerator, as Stan shows, and try it there. Another idea was to put this stuff into a solution of water and soap, and the bubbles would be magnetically, you could move the bubbles around with magnetics. That's a good idea. I have no idea if it's going to work, but it's worth a shot. But from my experience from Alex Petty and his work, even without the magnetic particles, he was basically just using hydrogen and oxygen from a cell, running it right through a magnetic field, and then into his gas core transformer, which he calls a gas core transformer, and he's getting good results out of that. So the magnetic particles, he's not even doing that right now. So it's very interesting that this stuff is actually being validated by other sources, like Alex, and they're not even doing it the way that Stan basically said that he was doing it. But the main thing I want to talk about in the particle generation is this right here, this diagram. You've all seen this, showed it to you. It looks like a chamber with 2 electrodes, and the magnetic vaporized particles are coming off of that. Okay, so I'm just going to read through a few things on the patent and go from there. So bear with me. I got it all marked through here. I just gotta go through. Alright, page 4. It says, still another objective of the present invention is to provide a generator for developing magnetized particles for the use in an electrical particle accelerator. So you have magnetic particles. We know that. That's a basic. That's what we've been talking about the whole time. All right, and it also says, therefore, the elements may be particles suspended in a fluid medium, such as a gas, a liquid, lightweight movable solid particles, and more preferably gas, which is what we are mainly going to be using in this device. At least I will be. In the application of suspended solid magnetic particles, it may be described desirable, to evacuate the tubing to reduce the resistance to its flow. So it says in the application of suspended solid magnetic particles, so not vaporized but solid, so maybe something along the lines of a ferrofluid, something of that nature. It's very interesting. It said it may be desirable to evacate, E-V-A-C-U-A-T-E, my English is awesome, the tubing to reduce the resistance to its flow. So, just something interesting that was in the patent there. But we're going to be using a gas, and probably not solid magnetic particles, so we shouldn't have to worry about that. But it's something to think about. He always talks about being pressurized in his other patents, but this patent he doesn't talk about anything about pressure. He more talks about vacating the area, so more of a vacuum, from what I'm gathering, or a vacated area of oxygen, ambient air, stuff like that. So if we're using argon, which is what I'll be trying first, if we're using argon in our gas processor, it's possible that the vacate is what he's talking about. Vacated chamber is actually just basically filled with argon or another type of gas and not ambient air. It's not necessarily a vacuum. It could be a pressure, but it's just a vacated chamber. So it's kind of hard to tell what's going on there. Another thing I got here, this is page 8. I'm just kind of skipping around in here in this patent. With reference to figure 9, let me show you that real quick. You always got to reference these things whenever you read through this. If you don't, this stuff doesn't make sense. I've tried it. You got to look at the patents and the pictures. Okay, there's 9. You got a mechanical pump and a pickup coil on the other side with magnetized particles in there. Permanently magnetized particles in that one. The one with the pump supposedly has permanently magnetized particles, where the other ones, I guess, don't. It's kind of weird. With reference to figure 9, there is illustrated a mechanical particle accelerator, that's the pump. In this embodiment, the magnetic particles are permanently magnetized prior to being encapsulated in a non-magnetic pipe. So that's kind of interesting. That could actually be some sort of a ferrofluid. It's a pump with a plastic propeller, but doesn't have to be gas, not necessarily. This particular setup, and he's later on electrically moving the particles instead of with a mechanical pump. He may have been trying stuff like ferrofluid. A guy by the name of Don, the same guy that posted the videos of Stan Meyer's estate, I was able to talk to him, and he's giving me parts of information that I'm trying to put back together with this. He hasn't studied the EPG system very much, is what he's telling me. But I talked to him, and he did find a picture of a ferrofluid bottle. It was 100 milliliters, is what he said. It said on the bottle, 100 milliliters, and let me find it. 100 milliliters, and it had a website actually on the front of it, which is kind of interesting for the dates. You got to remember the dates is another thing that's kind of confusing on this whole thing. It's like the first patent, but yet the ferrofluid had amazingmagnetics.com on it. So when did they actually have the internet? It probably wasn't back in the 80s. So it's real interesting. It's a whole nother conversation. Anyway, back to the fluid. So it could have been a ferrofluid. I believe he did try that. And then again, that Don said that could have been either someone else's or his father's or so forth and so on. We don't know. But it's just something to think about. Okay, here's the important parts that I've been rereading. And I've read this patent so many times, and each time I read it, I just get more and more information. So read the patents more than once, believe me. You'll pick out more and more things, like watching a movie. You watch a movie, you see things, you see more things and more things every time you watch it. It's pretty cool. It says here, Figure 10, in reference to Figure 10. I'll show you that so you don't have to look it up. These patents are all in the description. Everything that I am telling you and going to show you, I will have in the description, either under a downloadable link or something in that manner. This is the number 10, the one with the chamber and the electrodes. Okay, this is real important to me, and this is a good conversation for this video. It says there is an illustrated apparatus for carrying out the process of vaporizing material into vaporized particles, and thereafter magnetizing the particles by subjecting them to a magnetic field. Okay, so you vaporize the material, and then you run it through permanent magnets. That's what it's stating. Or a magnetic field. It could be an electromagnetic coil as well. It says the chamber 155 is a vacated chamber, having positioned in its lower half a portion of pair of electrodes of magnetizable material. Now the magnetizable material I'm going to be trying is iron, nickel, cobalt, and I've been trying some neodymium type of material. A source of voltage, this is the important part, a source of voltage provides voltage and current of opposing polarity. Okay, so I'm using AC right now for my setup, and he is stating that he's using opposing polarity, which would be a DC setup. And I have a little bit of verification on that. I'll show you. So we'll keep reading. Via terminals 154 and 156 to the electrodes. Via a wire connections, the area between the ends of the electrodes is the spark gap. Okay. Here's a pretty cool thing that I found. You'll like this. Alright, lost my page. It's alright. Okay. This is a connector. You see how it's solid? Here's another connector. You see how it's not solid? That, to me, would be indicating polarity. Alright? So, this is not an AC arc here. This is a DC arc. Okay? Those are my thoughts. And then my question to you all, does it really matter? You're still vaporizing material. I don't know. I really do not know. Good question, right? I know. Alright, let's keep going. Upon the application of power to the magnetizable material electrodes, the tip of the electrodes in the spark gap will be vaporized into particles. So earlier it kind of says what's between the spark gap will be vaporized, and here it says the tip of the electrodes in the spark gap will be vaporized into particles. Okay, let me look at something. Okay, so now let's continue. The particles rise. The particles 180 rise. Use and enter into a non-magnetic pipe. That makes sense. Into the particles progress in movement. They pass between the magnetic field generator. The particles each take on a magnetic charge as magnetized particles, and therefore are discharged via port 190 to the electrical particle generator above described. So that's just talking about after you vaporize the material, it goes through the permanent magnet setup and into the particle generator, which is what we're talking about. But it's real interesting. It says the tip of the electrodes in the spark gap will be vaporized into particles. So, you know, a pointier electrode would vaporize quicker, I'm sure, but that's just a way of stating it too. But it does say upon the application of power to the magnetizable material electrodes. Now that's in the older patent here. In the newer patent, he's using a hydrogen and oxygen mix within this tube to create the effect. So these two patents are probably talking about two totally different types of gas, in my opinion, because of the way it's all set up. The other patent I'm talking about is the other Canadian patent, gas electrical hydrogen generator. You can look those up. One of them is the Canadian patent 1228833. This is all in that document I've got posted on my description along with everything else. Alright, but it does say magnetizable material electrodes, which would be an iron, cobalt, nickel, something along those lines. And in his lecture he talks about argon and iron. Let's see what else I got real quick. Alright, this is on the very last page before you get to the pictures. An assembly, this is talking about that last photograph I just showed you with the chamber and the electrodes. That one there. An assembly providing a magnetized particle for utilization in an electrical particle generator comprising of a chamber and pair of magnetizable material electrodes positioned therein. A source of voltage/current of opposing polarity applied to said electrodes, and said magnetizable material becoming vaporized upon the application of said voltage current in the electrodes. A pipe connected to the said chamber and means to directing vaporized particles to said pipe. A magnetic field generator having the other end of a said pipe positioned within its magnetic field, and wherein the vaporized particles entering and being expelled to the said pipe become magnetized by passing through a said magnetic field generator. Which we've talked about. We have agreed that you could either use an electromagnet, and it states that, or it could be a permanent magnet. Okay. Right here. Right there. Alright, so DC versus AC. Your opinions on that? I don't know. A couple more questions. Another guy is working on this, and he was trying to figure out, do we need to, well, I'll tell you the goal. The goal would be to take a gas and ionize it, so you take away electrons, and then you vaporize like metallic ions, and then they would attach to the gas and make a gas lattice. His concern was, do you need to do this in separate time events? The first one being take away the electrons and then subject them to the ions to attach them. Do you have to use heat to attach the gas lattice together? I mean, how do we do that? In my opinion, and what I'm going to be trying, I'm just going to run it all into one chamber, and it'll all happen at once. The argon will be ionized, the particles will be vaporized, and you'll have heat within that arc, that spark, and all those things combined will combine these materials as they flow through this gas processor. I could be totally wrong, but again, even with Alex Petty's work, without using any gas processor of any type, he's getting good results. So it's worth trying on its own, and then running it through the processor, and then trying to ionize the gas first, and second, and third. Another thing I want to show you real quick. Be right back. Alright, here I have something. This thing got smashed. What this is an air ionizer. Creates ozone, and I would like to try to use this in this particular application of a gas processor. I don't really know if this would be good for this at all. Here's the device. So here's what it looks like on the inside. Might be hard to see, but this is a pretty big one. This is a real big one. There's the information on it if you want to look it up. But basically what it does is it creates ozone, and it purifies the air. It's meant to be in your house. Or actually this one's for industrial because it's giant. But I have two of these. One's smaller than the other. I got from a couple of closing stores. But you can see that it looks like a high voltage transformer in there. And what it does is it literally creates ozone. And surely there's got to be a way to use this in my application for processing my gases. So if you have any ideas or thoughts on that, shoot them at me. Send me an email or something. Alright, I think that's enough about the gas for now. Like I said, I'm going to be trying argon. Another thing I am going to, a guy by the name of Bill Williams, you got to get on the internet and Google his name. but he's created an open source hydroxy cell that's a split gas cell. A guy by the name of Mike Powers has also done this. His is not open source right now. I believe he wants to do that, but he's not ready, I believe. But once he does, that'll be good too. We'll have two different versions. But Bill has open sourced his, and he is willing to send me an old one to borrow. And what I'm going to do is, what it does is it's an hydroxy cell that separates the gas upon creation, or upon whenever you make the gas. It's got a membrane in there which allows electricity to flow through it, but the gas separates, and the hydrogen comes out one side and the oxygen comes out the other side. And it does it in such an efficient manner that you can take the hydrogen side and light the end of a hose and it will not flash back. It will only burn once it gets into the ambient air, because hydrogen by itself will not explode. And what that tells me is that you can take hydrogen, run it through my gas processor with this electrical arc, and that's when I'll be using my carbon electrodes. And then the carbon and hydrogen together will, I hope, create a much better, higher efficiency magnetic gas. Even though there's no metallic particles in it, from the research of Alex Petty, I feel pretty good about that. And Mike Powers has been working on this with me too. He's a real nice guy. Bill's a real nice guy. I've met a ton of people that are really wonderful people. Don, Matt, Blaine, all you guys. You guys are great. So let's get started on the core. We're going to talk about the core of the primary. I'm trying to figure out how this is supposed to work. I did not know if you should take the pipe, because it says it has a core. I'll read the first sentence on the first or second page of the patent. It says, the structure comprises a primary voltage inductive winding having a magnetic forming core. Okay, that's what it says. So if you look at the pictures, and all the pictures I've found, you can see that is on a core material over top the other pipe. You can see that there. Okay, so this would be like your either your copper or your plastic pipe. We'll talk about that in a minute. And then you have your core there. I was wondering, do you think the transition between the non-magnetic pipe and the magnetic forming core would be like a plastic pipe to an iron pipe, and you wrap the wire around the iron pipe and then transition back to plastic? Or do you just slide the iron or the magnetic forming core? Do you just slide it right over top the pipe? Luckily, later here, when I read it to you, it actually says that it slips over top of it. So it's not a piece of it. The closed loop tubing of non-magnetic material is continuous, and you slip the primary coil over top that. That's what the patents are saying. Alright, so I'll read a few more things here for you. It says here, the magnetic accelerator assembly comprises primary windings on a magnetic core. So, again, I was trying to figure out, is it an air core or is it not? I'm going to try both, but it looks like it's going to be on an iron core from what I've gathered. And that's what I'll be starting, and that's what Alex has tried too. He's tried all sorts of stuff. Alex has really done a lot of extensive research on this. I'm glad to be able to talk to him. Alright, right here it says, this answered my question I just told you. The electrical particle generation of Claim 4, wherein said particle accelerator further comprises of a magnetic forming core, and wherein said core has an opening slightly greater than the outside diameter of the said tubing adapted to receive the same. So basically, here's what I have. This might be pretty big for what I'm doing, but that is a 1-inch inside. I have a plastic piece on with a bearing on here because I'm going to put it on my lathe. What I was going to do is turn down little channels for my wire to sit in, but I don't know if I'm going to do that yet. I may just make divider plates. It'd be a lot easier for what I'm trying to do. But this is just a piece of iron, and it is a 1/2 inch wall thickness here, 2 inches on the outside and 1 inch on the inside. And it fits right over top of my piping. I'll show you. Alright, right now I'll be using this PEX pipe that I showed everyone in the last couple of videos. This one doesn't have it on there. But basically, this fits really nicely on there. It's got a little bit of slop, but when I get this on there, because this piece is so bent, it'll be straight here and then bend back around to my other particle accelerator, which I'll show you in a minute. Alright, so that's about it for the core. I was trying to figure out how that worked, and I believe that's how it is, from what I've gathered up from talking to people and from this information. Now, I would think an air core would actually respond faster, and you could do things faster with an air core. But this core, what it does, when you have an air core, magnetics are spread out. When you have a steel core of some sort, or some sort of a magnetic core, everything's concentrated around that, and that's a good thing for what we're trying to do. Okay, let's talk about the pipe. This is the big dilemma. What's the pipe made out of? The non-magnetic closed loop tube. Okay, what is it? There's a couple things. I know for a fact that the devices were copper, from talking to Don, which has personally seen these multiple times. And Don is the guy who created the Stan Meyer State videos, by the way, in case you didn't catch that earlier. So I asked him, that's what he told me. Let me read you what I got written down for notes. Da-da-da. Alright, soft copper. It's either 3/8 or a 1/2 inch, and I've confirmed that with a picture I've modified here. I'll show you that in just a second. 3 or 4 turns of loops, depending on what it was. The couple different kinds have different number of tube counts, looped tube counts. Can't speak. And so that's kind of confirmed. Now here's what's interesting. There's a couple ideas here that I need your thoughts on, and one of them is plastic versus copper or aluminum. I know that the devices were copper, and whenever you have a voltage running through a copper pipe, things are just different. Everything acts a little different than when you run it through a solid wire. And one thing would be the skin effect, what they call the skin effect. When you run electricity through any wire, when you get up to a certain voltage, you get this skin effect. And it literally, the voltage rides around the outside of the wire or whatever, which in this case would be a pipe. But you're not running electricity through the pipe, you're just running the magnetic particles, but it could be part of it. So here's what I want to read to you. This is just some very interesting thoughts. Now, if you had copper pipe, you're going to get a lens effect, in my opinion. But in my opinion as well, that might not be a bad thing. And here's the reason. If you had a copper pipe like this is its little piece, and you drop a magnet through there, you've all seen this. Oh, and it got stuck. No, it didn't get stuck. It just took that long. Okay? Yeah, it did get stuck. This is a bad demonstration. Try this way. Okay, here we go. Okay, see how long that took? It should have just fallen through there. Alright, everybody's seen this demonstration. If you haven't, try it on your own. It's pretty cool. But basically, the magnet falls real slow through there, and the eddy currents are created in this copper pipe. Now, here's the question, and this is real interesting. It says in the patent, an electrical particle generator comprising of a non-magnetic closed-loop tubing passing magnetic lines of force. Okay, if you're using plastic pipe, the magnetic lines of force would pass through it, and it would not be affected by the pipe would not be affecting the magnetic lines of force. But in the patent, and it says this a couple places, passing magnetic lines of force. Alright, when I dropped that magnet through this tube, it created eddy currents on the outside of this tube. Well, that would be passing the magnetic lines of flux from the magnet to the copper, and then to the outside of the copper to where the coils will be round. So in my opinion, even though you'd have Lenz's law drag, it may not be affected by the coil pickups. And that's just an interesting thought I had while doing all this research. Why would somebody use that much copper pipe when it would have that much of a drag, of a downfall towards your system? Either you didn't have plastic piping at the time, that was what you wanted, or you used copper pipe for a reason. Okay. Let me find another spot in here where it talks about. I think that's the only thing I had marked. There's another place in there where it talks about it, but it says passing magnetic lines of force. Now I may be looking at that too deep. I personally think that plastic would work better, but if you have this skin effect where you have a high, you just have things flowing across the outside of this tubing, and these coils are picking that up. I don't know. I am going to try both. I have gotten a couple of donations from people. Thank you. And I believe I will have enough now to purchase enough copper pipe to make this work. Copper pipes is expensive. If you guys know any plumbers that can get this for like real cheap, or got some scrap, let me know. It's got to be soft iron. I'm sorry, soft copper, the stuff that's in a spiral when you buy it. But it probably is cheaper just to purchase it here by the time you pay for shipping. So that's what I'm going to do. Now let me show you a video. I'm sorry, let me show you a picture of something. You guys will like this. This is pretty cool. This is kind of hard to see, but I will post this picture in the description. But what I've done is I've taken the, I've got Google SketchUp pulled up, and I've taken a photograph from a still from one of the images from the Stan Meyer Estate videos. Okay, here you can see the driver coils, and also in one of his lectures he talks about developing different things with his EPG system, and one of those things is more of like an oscillating field type deal. And Don has told me basically what this is there's a closed end here, and it spirals around, and then it comes out here, and then that's it. It stops. So this actually doesn't go closed looped all the way around. It actually stops. And what he told me, and what I thought of as well, is that whenever you'd energize this one, it would push, and at the same time you can energize this one the opposite way and pull. And what you can do is you can push and pull the gas here, which would push and pull the gas through this tubing. Instead of continuously running it, you're actually pulsing it, which was just an interesting concept build, I believe. But he does talk about that. So here's what I've done. Here's the copper pipe, and well, let me start over. This is 18 inches in diameter, from two different sources now. One of Stan himself saying it, and then also Don, which actually saw this stuff. I've gotten 18 inches diameter from the outside to the outside. So I stuck this in Google SketchUp and drew a circle 18 inches in diameter here. It's hard to see, but 18 inches there. Alright. And then what I've done is calculated everything else. So the width of this pipe, I calculated between 3/8 or a 1/2 inch, which is exactly what Don told me. Here I got 1/2 inch, but here I got 3/8 or 1/2 inch because it was, excuse me, it's really hard to tell. The photograph is extremely blurry. Here I was trying to measure the width of these coils. I got about 2 1/4 inches, and then for the width of the coils I got about 5/8. And oddly enough, these bobbins here are almost identically to those sizes. Unfortunately, they don't fit on my core, so I'm gonna have to do something about that. But I'm going to have to make my own divider plates. I was thinking about just using good old CDs here and making my own divider plates. But let's keep going. Alright, the coil length here, I've gotten written down 3 1/8. And then the width of what looks like the core material is going to be 3/4 of an inch. It's what it looks like the inside of the core material is. So the inside here. The other thing I measured was the width of the outside coils. I got 5/8 of an inch wide. I've got 2 inches this way from the outside of the bobbin, and the actual wire itself I got about 1 3/4 inches. Okay, so I drew that up in Google SketchUp real quick. I just wanted to do that. So there's your 18 inches in diameter. There you can see the width of both of the outside of that and the where the wire is at, and then the width. Alright, and then I got the the core material there looks like about 3/4 of an inch, so the pipe's going to be like half, or what we talked about, 3/8. Alright, and then you got 5/8 for the width of those coils, 3 1/8 for the length of all of it together. The width of the coils, I got about 2 1/4, and then there's my tubing size. So that I thought was very interesting. I thought I would try my best to figure out dimensions, and I have one dimension, 18 inches in diameter. I calculated everything else off that. I thought that was pretty cool. So that was one thing that I did do. Alright, I'm going to give you a quick little update on the things that I've been working on. Starting particle generator here. This is my gas processor particle generator. This is a 4-inch. This is the third time I've tried to tell you guys how wide this PVC pipe is. It's 4 inches. Last time I tried to tell you, my capacitor exploded. That was awesome. But that's a 4-inch piece of pipe here, threaded on both sides. I put a piece of plexiglass underneath the inside of that one so I could see in there. I got nipples sticking through here, they're meant for air, and they hold my you can see they hold my electrodes in there. And then I got an input and an output, and I'll be hooking this up to this particle accelerator that I built. This is just a test. 3/4 inch PEX here, 1/2 inch input, which is probably plenty big. Could have probably made it real small, but it's just what I did. I got to put a gauge on this yet to find out the pressure inside here. My core material will be placed across here with my coils around it. Let's see, I'll be using, I got my argon tank right here. I was lucky enough to have a welder, so I have argon to use for this testing. Here's my high voltage transformer and my capacitors. I'm going to have to, I guess, use some sort of a rectifying diode. That's another thing I need. Does anybody have any high voltage diodes or high voltage capacitors they're willing to either let me borrow if I don't blow them up, or you can send my way. Let me know. Send me an email or something. But here's my carbon electrodes, and this will be used for the hydrogen oxygen side of this experiment. And another thing I got, while I got this core material, my cousin owns a steel manufacturing shop, and he allowed me to, he donated a couple of pieces of tubing and this core material for me to use for this experiment, so that was pretty cool. But what I did is I got some stainless steel here of various sizes, and these are for the water fuel cell, and they're just some random sizes that fit inside each other. You can see, I believe the smallest ones I got is about 3/4, and the biggest one I got is 4 inches. This is a big one. So that'll be interesting. Different sizes of thickness in between here. And it's just for quick testing. But this is all 403 stainless. So that's a good thing. Another thing I did on my YouTube, basically I'm going to start incorporating a new name with what I'm doing. And my research is going to be called RWG Research. And it's just an open source research. My form, whenever that gets put up from a guy by the name of Matt, it will be under that, and we can go there and discuss all this information in one place. So if I'm working on a certain project and I need people's thoughts and ideas, and then other people are working on that as well, they can go there and we can collaborate. Instead of posting on multiple forums all over the place, we'll be able to collaborate on one forum that basically I'll be using, because I can't keep up with all that other stuff. There's a lot going on in life right now, and it's just the way it is. So I'm trying to, Matt is trying to help me do that, and also get donations coming in. Again, if you would like to donate towards this research, it's all going towards building these devices, and I mean, that's it. In return, you're getting information, thoughts, seeing things being built, and hopefully we can change the world together. You can send money to RWG rdwg42985@aol.com via PayPal, or if you want to send donation of parts, pieces, materials, there's a document in the description that you can open up and you can see what kind of parts and pieces that I need. I still have to add high voltage diodes and high voltage capacitors on there, but that's it. I don't really have a whole lot more to say except for thank you. And if you can't donate resources and you're wondering what you can do, donate your time. Go to the description, download these patents, read through this material, give me your thoughts on it, because every person in the world sees something in a different manner, and it's going to take us all together to make this actually probably really get a good enough information here to make something extraordinary. We're all going to have to work together. Okay? So it's about us, not about me, and this is open source RWG research. Hopefully the website will be up soon. Matt, thank you. And everyone else, thank you. I'm gaining more and more and more information and more contacts. Like I said, the best way to get a hold of me is through AOL. My email address, rwg42985@aol.com. If you're watching this video on another channel, my original YouTube is rwg42985. Go there and you can get a hold of me there, or my email. So this video information, anything is free to give out. Download this video and upload it. I've got another downloadable link directly to a server that you can download this video, so you don't have to download it from YouTube. Alright, check the description and have some fun, people. It's all about having fun and learning, and I'm here with you, and that's it. So this is Russ. Today's date, I believe, is the 28th. Yes, March 28th, 2011, and tomorrow morning me and my wife are going to be having my second baby. So wish me luck. Alright? Peace, everyone. Have a good one. Be blessed, and be safe.